Today, we're going to be creating a throughput monitor of resources using the integrated dynamics mod. I haven't found anything online or any videos or anything on how to do this, and it took me hours to figure it out, so I figured I would share what I found. Welcome to our sandbox world here. We've got a little demonstration set up. It's almost identical to my other world. We have a generator creating cobblestone over here. We've got some crushers turning that cobblestone into gravel. We've got a chest right here for our throughput storage, and then we have our actual machines here, and these are processing our gravel into a lot of different resources, which we're currently just throwing away. But I'm going to demonstrate how we can identify how much gravel is actually going through these pipes at once, and so, or per minute, I mean. So we're doing this with integrated dynamics, and we're going to be using these machine readers. And there's a lot of different readers that integrated dynamics allows for, and they can do really cool things. Some can tell you if it's raining, some can tell you if there's liquids inside of a block. There's all kinds of different things. But the one we want is the machine reader, and this is the only one that can actually do what we're looking for. So you need one machine reader for every single block that you want to track. So in this case, we have two sieves, which are both processing gravel. This one's doing most of the work just because of how we routed this chest. This one's not doing very much. This one's full. And so we want to know how much both of them are using. So we're going to put these machine readers facing both of them. If you only had one machine that you were interested in, you could just use one. If you had three, you could use three. And then we're going to do addition later with our variable cards here to just bring the two totals together. So go ahead and craft some machine readers and some logic cables. In survival, this isn't a particularly expensive thing to do. In my skyblock, I think I got maybe 2 stacks of mineral logs for all of this, and it was more than enough. So if you've got some mineral logs, this is going to be more than enough resources to run this. This is actually a pretty cheap thing to create. So put these machine readers down, however many you need to calculate, and then connect it with logic cables. These don't require electricity, but you just need the logic cables to be connected to each other. And then we're going to have a display panel here, which is going to tell us our number of how many blocks per minute. And then we're going to connect it over to 2 delayers, a variable store, and we have a logic program over here. This doesn't have to be connected, it's just a functional block helping us to create this whole system. So essentially the way we do this is we use a really clever workaround, which is calculating how many blocks it's using based on how much energy it's losing. So because there's no metric in any of these readers that tells you how many blocks are coming in or out or how much processing is being done, we can only calculate this using how much electricity is being used, which is actually relatively easy to do. Our machine here literally tells us the RF cost per item is 2,560. So it doesn't matter how many items you have, it's always 2,560 each. So you can see this goes down just a little bit for a blip here because it's not processing that many blocks. But over here, when we're actually hitting all 64 blocks, you can see this energy is taking a big hit. And how much of a hit it takes is going to calculate us how many blocks, because we know it takes 2,560 per block, so we can figure out that drainage and get ourselves a total. Now you could do this with mechanism too. So for instance, our crushing factory here, we've got 9 rows and we're making 5,000 FE per tick. And so we could just, divide this by 9 and we would know exactly how much each individual one was. So for our instances though, we need the machine readers, logic cables, variable stores, 2 delayers, a logic programmer, 24 variable cards is probably going to be plenty enough, display panel, and a labeler. I would 100% bring this. I had to restart my build multiple times because you use so many variable cards in this, you will just legitimately forget which variables you're using. So 100% use a labeler. It takes a lot longer, but it's really helpful. So first we're going to start with some constants because we need some solid numbers here, like 2,560 is how much energy it takes. And that's useful for us in our calculations. So we're going to our logic programmer here, and in the side here we type an integer. And essentially all these different things allow us to kind of manipulate these variables. These are all like different things you can kind of set this variable card to. So we just want a number. And so we're going to start out with 0. I'm going to change the name here. You can change the name if you have a labeler in your inventory. We're going to change it to const 0. We're going to take this out here, and then we can see that nice name on top. We're going to create a couple more. We want 6. This is going to be const 6. And then 6 is going to be for a minute multiplier. We calculate it over a 10-second period, and then we multiply it by 6. And then we want one for 2,560 because that is our FE per tick. So this is going to be highly individual, this number here in particular. But if you can identify exactly how much energy it takes per block that you're generating, that's going to be this number that goes in right here. So we can go ahead and set these up already. This is the constants. This is the easy part. We also need an addition operator. So we're going to go in here. This will come in handy way later. But we're going to type an operator here. We go addition, and we just put in 1 right here, and we can just keep operator. That's a fine name. We only use one of these anyway. Right, once we're done with that, we can head over here to the machine readers and scroll to the stored FE, which is the metric that we care about. And we're going to put in a variable for each machine reader so that we can see the stored FE for both. Now you only need one of these, obviously. We're going to rename these. You only need one of these if you're only using one machine. If you're using 2 or 3, you'll do it like I did. And we're going to add these together later. So if you have more than 2, you're going to have to do multiple additions. If you had like 3, for instance, you would add the first 2 and then add the third one to that result, for instance. We're going to go over here. We're going to go to addition, and we're going to add our 2 results together. So we only have 2 blocks. This is super easy. And we're just going to set this to our total FE. So this is all of our generation or resources required across all of our devices. We're going to put this in the delayer, and we need to duplicate it actually because you keep a copy in the delayer and you also keep a copy in the variable store like that. And in the delayer, we make sure the top one is 1 tick per operation and 1 capacity. And then we create a variable card which creates a list. So what this delayer is doing is it's getting the value from the last tick, which allows us to compare the difference. We're going to name it memory list. This is a list. It only has 1 value because we only set 1 capacity, but we can go to get or default in our processor here, and we're going to put in our memory list that we just made. And this is where our 0 const is going to come in handy. This is basically telling it, look at the first index, which is our only index. And if it's not there, then just report 0. So this just keeps us from having any issues. We're going to create this, name it past FE. We're going to go into subtract, and we're going to subtract that past FE from our total FE, which is going to give us our delta, or our difference from what it's normally when it's full charged and what it just was after a tick update, which was it processing a bunch of blocks. So now we have FE1 and 2, our delta, our past, and our current total FE. We can go ahead and plop some of those in there. Now we're going to go to max, and we're going to throw in our FE delta and a constant of 0. This is going to make sure that we have an absolute number here. So essentially this is making sure that when we're losing blocks, we're only counting the positive coming in. We're not counting the negative going out, which keeps this from being net 0. So go ahead and put max, and we're going to name it clean FE spent. We're going to go ahead and duplicate this because the other one is going inside of the other delayer. So we're going to this delayer right here. Put the clean FE spent right there. We're setting our ticks per operation to 1 and our capacity to 200, which is 10 seconds. There's 20 ticks per second. And we create a variable card for that. And we're going to rename it to 10-second history. So this is the last 10 seconds of any changes in electricity. Now, if you look at the first delayer, you'll notice that number in there. We don't currently have anything in there because we have some variables we haven't put in the storage yet because we're still in the process. Now we're going to go back over here and we're going to reduce. So this is essentially taking all of the positive values from our 10-second history. So anything that wasn't 0, We're going to put in it for our list. The operator is the operator we created earlier in the first slot. That's our plus. And then our const is 0. And we're going to create a new variable for that. And we're going to name this one FE in 10 seconds. So the last 10 seconds of FE, the total amount that was used. Almost there. Next, we're going to go to division. And we can put in our FE from 10 seconds. This is the total we made in 10 seconds. And we can divide that by our constant of how much it is per block. So now we know how many blocks were generated in the last 10 seconds. So we're going to name this items in 10 seconds. This is the amount of items we generated in 10 seconds. And you could put this into your display right now if you wanted to, but we want to know how many blocks it is per minute. So we're going to lastly take this last one, items in 10 seconds, and we're going to multiply it by our constant of 6. And that's going to give us an accurate gravel per minute metric right here. So now we have our final items per minute variable right here, and that's the last one we want. And all of the rest of this stuff now goes into variable storage. So I kept it in my inventory because it makes it easier to craft all these, but in the end it all goes in here, and we put that final into the display, and now we have a solid number between 800 and 1100. So I want to increase this number, so I'm going to reroute my transporter super quick. And essentially what we're going to do is we're just going to reroute these pipes so that we're sending in more gravel, and then we're going to hopefully see that number increase by a couple hundred or maybe 1,000. Now, as you can see, our number has increased. So we increased our gravel input, and as you can see now, we're in the 1600s to 1900s, 2000 right there. So we're going through nearly 2,000 blocks of gravel per minute. Now you might be wondering how we know if this number is accurate or not. And you could just put an export chest and watch it for a minute and, calculate how many it put out and see if the number matches. Or in our case, these are based on random drops. So putting in gravel with this mesh has a 4% chance of dropping an emerald. So let's say we wait for a minute and we get a stack of emeralds, and then the next minute we get like 80 emeralds. We can put this in the calculator and we can actually figure out based on probability about the kind of range that we're dealing with here. All right, so I know it's a bit convoluted because we have to calculate the energy usage per block rather than just having a simple metric like, oh, how many blocks are going in and out. But I think this is a pretty clever workaround. I couldn't find anything online about this, so I spent a couple hours working on it, and hopefully this was helpful for you. So thanks for watching.